All right, you see, this is the second part of this today's lecture because I already recorded the first half, but you didn't have a chance to see. But I'll tell you a little bit about what those materials are. Again, you see the naming of this one, lecture 202B. That means this is the second half of the lectures. The first half is already pre-recorded, and we already I probably uploaded it. I will check, but you have not seen it. But I'll summarize a little bit what we learned in those last two class. Typically, what I'll do is I'll I'll keep those recorded materials at least 3 or 4 days advance of that class, so that you have a chance to listen to those before coming to this class. This week was unusual because again I'm still learning about recording. But for the next class, we'll have all the recorded materials available by Monday or before Monday. So that means you have enough time to listen to those or watch them before you came to this class. All right, so let me tell you a little bit about what we have in those pre-recorded materials. You can see over here, this was in the second half of the last class, which we didn't have a recording before. And these are the 4 questions you should be able to learn, if you listen to that. These 4 questions are, find 3 different reasons why there are water scarcity in urban areas. Find at least 3 negative impact of stormwaters or runoff. And also understand the difference between gray infrastructures and green infrastructure. Again, those are very basic questions. These are all conceptual questions. There are nothing really about quantitative part of these questions. So that means if you read that handouts that I provided, or if you just watch that video, you'll be able to get that answers. At the end there, what's the 3 benefits of green infrastructures? Again, we discuss about many benefits. You should be able to get that from those previous class. So that's the second half of the last class. But if you think of the today's first half of the class, which I recorded and uploaded, these are the 4 questions you should be able to understand from those materials. The first question is identify 5 types of pollutants or pollutions caused by stormwaters. Here I'm asking what are the different pollutants you can expect in stormwater. Again, these are heavy metals, pathogens, organic, pesticide, you name it, many different types of pollutants. Again, you can watch those to understand the source and other factors. Then next 2 questions about long-term and short-term impact of those pollutants. These are just one slide, so you can see that some impact, like let's say flooding. Flooding can occur within few hours after the rainfall. That means those are short-term impact. If you are looking for how much sediment deposit on the riverbed, those are long-term impacts. So if you are thinking of let's say venting sediment contamination in lake, you can expect those to occur in year scale or many years. It takes time for that to happen. So that's what my question is about. The last question, question 4, is about write at least 3 causes of contaminant concentration variability in stormwater. In fact, you're not able to understand that if you listen to that other video because I really didn't cover it. I put the question without realizing that this is part of these lectures. So this is the objective of this particular 1 hour of lectures. The first objective is about environmental regulations. Again, the green infrastructures are designed because they have to design. If you ask them a permission or give them a choice of whether you increase green infrastructure or don't have green infrastructure, nobody will have green infrastructure because it costs a little bit extra money, even though it has a lot of positive impact. So many agency or many municipal agency will not have enforced this green infrastructure unless there are regulations. So we'll learn about what are the different regulations that force municipality or different agency to have green infrastructure in those regions. Then the second or third questions or all those next questions all about consulting company. If you start working, these are the questions they'll ask. These are the questions you should know. First is maybe in your first job, your job is to collect stormwater. So you should know how to collect stormwater. You should know different different side effect in the sense what you should not do, what you should do when you collect stormwaters. We'll learn that in these lectures. Then also another part of stormwater monitoring is when you should take samples. What do you expect now? At what time the concentration should be high? As you know, concentration of contaminants in stormwater can vary very widely. Depends whether you are taking samples at the beginning or at the end of the storm events. The concentration can vary by order of magnitude. So you should know at what point, what location you should collect samples. And we learned that today. And there is a very specific term that people use, first flush phenomena. That means the very beginning of the stormwater or the very beginning of a storm event, everything that happened initially is the first flush. So that's the first time all the pollutants are being flushed out from pre-rainfall conditions. So how to quantify that? How to identify that? So that's the big part of the stormwater management. At the end, there is a regulatory term, TMDL, that means total maximum daily load. This is how municipal agency quantify how much pollutants are discharged via stormwater to local water bodies. So we'll learn about all that today in this class. Again, these are the four questions you should think of when you listen to these lectures. So as you listen to all the different materials, you should be able to answer these particular questions. First is what are the different regulations that affect stormwater management and how they are enforced. Who enforce that regulations? Is this federal agency or is it a state agency or is it a local municipality? So you should be able to answer that questions in a couple of slides. Again, learn about sampling methods and handling, particularly what are the different precautions you should take. The third one is about the cause and importance of force flush phenomena. At the end, you have to measure the concentrations, how to quantify that. So those are the quantitative part is the last questions. So we most likely cover 1, 2, 3 very easily, and the 4 one is mostly derivations. I don't want you guys to sit here while I derive it. So maybe that part I'll record and upload later. It will be 5 or 10 minutes, but still I don't want you guys to just watch me deriving it. You can watch it later. All right, the first one is regulations and ordinance. If you go back to the different act, 1972 Clean Water Act, that's the very first water act about to enforce how much wastewater should be discharged into stream. So this is not about stormwater, but this was designed because lots of people our municipality was dumping wastewater without treating them into the riverways or into waterways. So that law determined how much maximum contaminant amount you can discharge into water bodies. It's not about concentration, it's about mass. That's why it says maximum daily load. It's a mass, it's not a concentration term. Basically, this means concentration times volume. So even if you have low concentration of stormwater or recycled water, you can discharge high volume of those pollutants. If you have very high polluted stormwater, that means you discharge small amount. So this is mass based because that's the amount of contaminant will accumulate in those systems. If you want to learn more about it, again, these are all basically regulatory terms and concepts. You should go through these links and read those. These are essential for your interview question. You should know what are TMDL, how they are implemented. I'll just briefly describe how it works here. Again, TMDL means what concentration is permitted. Even though it's a mass term, there is also a concentration term. That's based on the acute toxicity. Because if you discharge very quickly, very high concentration, that might actually be highly toxic to some aquatic organism. So there is also a concentration term. But at the same time, if you have concentration problem, you can always dilute it and discharge it. There you are in regulations. The TMDL concentration vary based on water bodies. Why it is because TMDL term is related to the intended water use. For instance, if that lake is used for drinking water, the permit has to be more strict because you are drinking that water, the pollutant concentration has to be very, very small. But if that lake water is not used for drinking water, the TMDL will be much higher. That means you are permitted to pollute a little bit more. So again, this TMDL is determined by end use, not necessarily, there is no one single TMDL for every lake. If there is, for instance, if you think of LA River, there is a TMDL for LA River because those are based on what that water is being used for. That water is dumped into bay that goes to the Los Angeles harbor. So that means those are based on the toxic effect in that regions. Same thing, if you think of a wetland, you will also have different TMDL. You can actually look for all that on EPA website. In fact, that's exactly one of the homework questions, to look for TMDL for any particular water bodies near your home or community, so that you know exactly what's the different types of pollutants should not be discharged into that system. Again, this is not enforced by EPA. EPA just create a regulatory term. That means everybody has to create their own TMDL. That enforcement is based on municipal agency. That means LA County is going to enforce what's the TMDL limit for all the water bodies inside it. It's not enforced by EPA or state agency. So if there is a question on quiz, who enforce it, and if you write EPA, that's the wrong. EPA only oversees that. EPA enforce that. EPA ensure that all the municipal agencies will create their own TMDL. So that's the regulation. That's where it stops. Again, all the municipal agency, based on MS4 permit. MS4 means municipal sewer, because that's the one has lots of pollutants. That's why it is that's the regulatory term. Anytime you hear MS4, that's municipal sewer permit. Again, you can see that National Pollution Discharge Elimination System, that's NPDES. That's the system you can check online. The link is provided here. You can go to that website and you can look for any particular water bodies, and then you'll find that TMDL for that locations. And there are also local ordinance. For instance, LA has two more ordinance, stormwater ordinance. One is 1998, another 2011. That's based on low impact development ordinance. That means who are the agency that should develop their property or include low impact development in their property. For instance, think of you are buying a land which has 4,000 feet square feet, and you are going to design it certain way. But now, when you design that, you might create lots of impervious surface that will pollute the river or the water bodies. So that means now municipal or LA County can come in and say that, look, you have 4,000 square feet. You cannot keep entire 4,000 square feet as impervious surface. You have to have some kind of green infrastructure to manage the stormwater that is in your property. So those ordinance is based on 2011 ordinance. Again, we have also stormwater ordinance in 1998. That's basically about how much discharge you can have from a particular site. More recently, that's 2018. This is very particular to LA County. Measure W, that's basically a tax system. That tax system is called parcel tax. That means if you own a property and if you have certain amount of impervious surface, you pay a certain amount of tax per year. That's 2.5 cents per square feet of impervious surface. That means you pay that much money per square feet of impervious surface in your land per year. That generates high amount of very large quantity, large budget. For instance, LA County has $300 millions to spend on green infrastructure project for every year. This is per year. That means you can expect there are so many different types of green infrastructure projects that will come on next years. So if you think of a job for green infrastructure project, this is the time. Next year there will be a lot more job on those particular type of projects. And again, this is ongoing for every year. So this is a good time to get into this particular field. Then there are many local regulations. As you see, I provide some of the other ordinance. I don't have
Professor,
to. Yes.
I have a question.
Yes.
So you said something about the LA County having certain regulations and certain standards that one needs to meet in terms of having pervious surfaces. So like, what's the minimum standard they need to meet? I guess in a way I'm trying to ask is if there's still a lot of runoff being generated during rains.
Are you asking about a question about the volume or the concentration of pollutants?
Just the volume and yeah, if they
So,
have like they meet
mhm.
the kind of concentration of pollutants which have been established.
So I guess, again, that there is no a minimum in the sense why is because that's based on TMDL where that stormwater is getting into. So there is minimum drinking water quality standard. For instance, for drinking water or surface water, you need to have this much maximum concentrations. So those are related to drinking water, and that's also enforced in a certain way. Those are for drinking water act. So those are also same for stormwater. But again, stormwater management is all about TMDL, how much pollutants are actually discharged into a system, because whole point of stormwater is protecting the water bodies. So those are the priority in terms of concentrations and mass. There is no single answer for that, unfortunately.
Right. And also, is there like still runoff which is being generated?
Yes, yes.
Right.
As we learned through that, you can't make the runoff zero. When you think of green infrastructure, they are designed to reduce the volume. It's not going to make it zero. It's going to reduce the volume. It will decrease the peak. We'll learn that in the next couple of slides.
Perfect. Thanks so much, Professor.
Thanks. And also, I want to mention this is the three link that I provided here on the right side. CACGP, Construction General Permit, Stormwater Pollution Prevention Plan, Erosion and Sediment Control Plan. I'll share the PDF of those plans for LA County. If you are going for interview, if you just mention those names, they know that you are aware of that. They will be impressed. So again, I will share all that in the hope that if you are looking for a job in this particular sector, you should at least skim through that and just see what are those. All right, the first thing in your job, imagine you got a engineering jobs in stormwater consulting agency or industry. The first thing they will ask you is to go ahead and look for collect stormwater samples to send some locations. So there are specific way you'll collect samples. You have to make lots of decisions, and that's what you're going to learn just now in a couple of slides. Again, you know that when you're going for monitoring, you are looking for all these different pollutants. 8 pollutants I say, there are many other parameters you'll measure. So that means each parameters can be affected based on how you sample it. So for instance, think of sediments. To collect sediments or capture sediments, you take stormwater, you take a bucket and you collect stormwaters, and you keep it for let's say 2 days. You know that sediment can settle. That means if you send sample from the top surface versus bottom, you'll have very different concentrations. So that's why it's very important to know how you collect sample, how it become the representative samples, and how you store it and how you analyze it. Again, monitoring the first priority, because if you don't monitor, you don't know the problem. If you don't know the problem, you don't know what to design for, why you are designing these green infrastructures. Because there are many types of green infrastructures, the design has to be very different based on what pollutants you are targeting to remove. So again, I want to mention that concentration can vary widely. It's event-based, means based on what time, what kind of events, whether it's a 2-hour rainfall or it's a 1-hour rainfall, the concentration can vary. Even within the events, they can vary a lot. So that's why it's very important to know what time you have to take samples. And these are the challenges of concentration determinations. Challenges. First is unpredictable. That means the concentration you expect at any time will vary widely. That means you don't know whether the samples that you collected is a representative of the actual concentrations. Depends on local climate. As I said, if you have a very heavy rainfall, it will dilute a lot. That means the concentration can vary quickly. Again, concentration depends on the locations. These pollutants are accumulated on the surface for a period of time. That means depends on where you collect the sample, the concentration can vary widely. The last one is also there are many types of pollutants. And for each type of pollutants, there may be specific strategy. For instance, if you are collecting for nutrients, what kind of sample container you should use? Those are all matters. If you are collecting for pathogens and you are using a samples that has already pathogens, you are influencing the results. So how do you clean those sampler? All that factors is influenced by these decisions. So again, what time you have to sample? So think of, this is very related to one term that you always hear now because of COVID virus. One is flattening the curve. In fact, this term is coined by hydrologists. If you think of what that means, all the stormwater infrastructures are designed to handle certain amount of water. If you have more than that, all those will overflow. That means they'll exceed that capacity. So every time there is a rainfall, I'm going to plot the graph based on time and peak discharge. Q is the discharge volume over time. Okay, and this is time. Imagine the rainfall happens, and I'm going to, for simplicity, I'm going to write rainfall as a rainfall start is the same rainfall intensity to stop here. So this is rainfall intensity. And now you are collecting in, let's say this is the watershed. This is the watershed and you have rainfall here, all over same intensity. And you are collecting stormwater here. This is your sampling location. So all that storm will drain into that particular location. It takes some time. So that means you can expect the discharge will be initially very small. And as it moves, it will continue to increase until the rainfall stops. And then it will start to decrease. It's not necessary that this will coincide with the peak discharge point. It depends on the size of the catchment area. But point is, this is your peak discharge. Imagine your pipeline and all that system is designed to hold this much water. This is the capacity of your municipal system to discharge storm water. That means after this point, you will start having flooding. That's what we call flattening curve. That means if you have green infrastructure, you reduce that peak discharge. So this is without green infrastructure. But if you do with green infrastructure, I'm going to use a different, this peak will be a lot less. So that means always it will be less than the capacity. So this is with green infrastructures. Now question is, this is the volume of water that comes through that sampling locations. What about pollutant concentration? Where you expect the pollutant concentration to be the highest? You could have three choices. Maybe it will be in the center. Wherever there are lots of water, that's the time you'll have high concentration, or it may be later, it may be earlier. But if you think of how the pollutants move, usually most of the pollutants are accumulated on the surface, and initially all the rainwater or the surface water will wash them off. There is no constant input of pollutants. It's all there to begin with, and everything can be washed off quickly. So that means you can expect that most of the water that comes very early, this is the location where you can expect very high pollutant concentrations. So if you take water samples and start measuring concentration of pollutants, you might expect something like this. So we call this is pollutograph. Means if the concentration of pollutant over time, and this is called hydrograph, or the amount of water discharged at a point over time is called hydrograph because this is related to amount of water. So there is one question: at what point you will expect high pollutant concentrations? You can expect that before the peak discharge. So that's the quiz question. That could be one particular quiz question. Again, what you learn here that pollutant concentration can always come previously or come first before the peak discharge point. And that concentration, as you can see, it can vary based on what time you are taking a concentration of taking the samples. So that means if you take a sample here at the very end of the rainfall, and you say this is representative of the samples, then you under predict the amount of pollutant discharged. And if you take the samples at the very high peak, that means you over predict the amount of pollutant discharge. So that's why usually when you think of taking samples, you take multiple samples during the storm events. That's why any times people say that I take 1 gram sample and this is a concentration of contaminants. That's wrong. Gram samples do not represent the actual concentration. If you do take gram samples, you expect to take samples at multiple times and mix them all together to create a composite samples. So this is why these are different types of sampling plan exist. For instance, here you see at the very bottom, this is a grab sampling method. It's called grab sample because you just grab a bottles and you collect samples over here. So that's grab samples. And this is an automated sampler. The reason automated samplers are there is because of this whole change in concentration. Instead of picking one particular time, auto samplers take samples at different time. There is a pump inside it that pump water at different times and then fill different bottles. So that's why it's auto samplers. Now, how frequently you should use, that's based on the storm event. If the storm event lasts for 1 hour, you should at least try to measure as many times during that 1 hour. The frequency depends on the how the peaks increases with time. The location also depends on what location you collect. If you think of entire stormwater, you can collect one catchment area. For instance, in the previous site, if you collect water over here, this is the catchment area, you are accounting for all the stormwater. But if you are collecting sample from here versus here, you are not really accounting for entire catchment area. So that's why it's very important to know at what site you should collect so that you get a homogeneous mixture of all sampling or all stormwater. Again, when to take samples, I already discussed this one in detail, so I don't need to go over. Just to main point here is the time of sampling is very critical because it determines whether the sample has high concentration or low concentration of contaminants. And usually the pollutant concentrations or peak of pollutant concentration precede the peak of actual discharge of stormwater. And by using green infrastructures, you can usually flatten the curve. Means you can remove the pollutants, not only remove the pollutant, you delay that peak. So that's the whole reason why green infrastructures are designed. Any
Also,
question?
Professor,
Yes.
will this lead to contamination of groundwater in any way?
Yes.
If you use green infrastructure?
Yes or no, in the sense it depends on the type of green infrastructures. In Los Angeles, the most common green infrastructure is a dry well. Means you just create a big hole and just dump all the stormwater in it. That means you are creating short circuit to allow those pollutants to get into groundwater. So that means, yes, that point it will increase the groundwater pollutions. But they do that in the coastal area because those groundwater is not used for drinking water. So that means you can do that there. But if you have a location where groundwater is used for drinking water, you cannot use certain type of green infrastructures. But there are many other type of green infrastructure. It can remove pollutant and diminish the contaminant transport to groundwater. And we'll learn that all those techniques.
Right. Thank you.
All right, so one question was, what is first frost phenomena? Again, first frost phenomena is the fact that most of the pollutants comes early in the rainfall. That's why it's called first frost phenomena. That means if you see in this graph, particularly here, this is a study done by Professor Mike Stenstrom. He's in UCLA. He has done a lot of work on stormwater in 19 early 2000s, and this is one of his paper. As you can see over here, the top over here, those are rainfall, and the very bottom, that's the rainfall intensity, and the very bottom is time. You can see over here there is a different pollutants. Over here, this is COD, BOD. These are all different pollutants you see. As you can see, think of the blue line. That's the chemical oxygen demand. That's basically nitrates or nutrients. You can see over here, those come very quickly. Those are essentially the leaves and debris and all that nitrate coming from that. VOC, that's also the same thing. That's why you see most of the peaks are very early, because that's where you flush out all these debris. If you think of the next one, for instance, here, this is the flow. That means, I'm sorry, this is the flow. Flow means, that's where the peak discharge is coming from the from the water side. As you can see, the peak for pollutants uh, for pollutants is coming much ahead of the peak of flow or flow. That's essentially we discussed later. So that's why it's called first flush, means the very first time you see high concentration of pollutant in stormwater. And it's very difficult to actually determine exactly what time it will come, because that depends on how big the area you are considering and how big the rainfalls are. So this is something subject to discussion, in the sense that there are lots of studies to determine at what point you should collect samples to capture that peak discharge for pollutants. If you don't know when, you just have to keep collecting samples. For instance, in this site, they say it comes around about 100 minutes. But if you see, they really didn't take sample before 100 minutes. So that means they don't know whether the peak discharge is 100 minutes or not. So that's why it's very important to collect sample before that too. So it might have been like this, who knows? So again, this is a particular process you should remember. Why it is important? Because if you think 90% of pollutants are discharged during the first flush, that means you don't really need to treat all the stormwater. All you have to do is treat the stormwater which has high amount of pollutants. So that's why your green infrastructure has to design such a way that it can treat actually the first flush. Everything else you can actually don't have to treat and still maintain your discharge limit. Again, we discussed about that, how to sample. You have choice of graph sample versus automated sampler. And that depends on, if we have a choice, we should always use auto sampler. But auto sampler cost about $10,000 a unit. That means it will be very expensive. It has benefit, but it's highly expensive. You have to secure it. You have to make sure that nobody steal it. That's why it is very important to use those. Let me see, there is somebody sent a questions on chat. Let me see where is. The question was, hello, Professor, can you please explain again how they know where to sample runoff? David, yes, that's a good question. That's subjective to the locations. Usually, if you are talking about stream, it doesn't really matter. It's all about whether you are collecting from you should not collect sample from the very edge of the stream, because that's where the flow of water is low. So that means you can collect from towards the center, as long as you can assess it. If you are collecting from lake, same thing, you should collect at multiple locations based on where the discharge, the stormwater is getting into the lake. If you are collecting from any other water bodies, you have to make that decision based on where how the concentration may vary based on the flow at that location. We'll learn all that as when we go to that individual water bodies. But just know that location can make a difference. Good question.
Something related to this question, Professor.
Yes.
Uh, would you, when sampling, would you sample also in different points of time to sort of get like a curve of pollutant concentration, so you know that at this point in time we have already observed maximum flow of pollutants?
You do that if your goal is to understand when is the first plus occurs. If your goal is just to know what's the concentration, what people do is they actually collect hundreds of samples, but they mix them all together. The reason is measuring each sample is expensive. So if you don't have enough budget, what you do is you create a composite sample out of all those different samples. So again, it all depends on what you try to address. Because ultimately, all you care about is TMDL. TMDL is, if you think of TMDL, TMDL is a concentration times volume. You know the flow rate, that means you know how much water is being discharged. That means you know all you have to do is measure the concentration at that particular time. So that means you can measure concentration at different time and volume of the samples or discharge at that time and sum it together to get a TMDL. Or you can assume that the average flow rate in that site, so V average and C average. And so when I say this one C average, that means the composite samples. You take small amount from each sample point and then mix them together, homogenize it, and then measure the concentration. That will save you the analysis cost. It's all again
And
depends on what's the goal and how much budget you have. Ideally, we should collect as many samples possible and analyze all of them.
right. Also, just to be sure, the Z is a correction factor.
Oh no, I'm sorry. This is concentrations. This is concentration. This is volume of sample or volume of the
Oh,
storm.
that's a sigma
This, oh,
before
I'm
that.
sorry. This is a sigma because you are taking many samples, so you add up them all together.
And would you oh, okay, and you don't like divide them by the volume, right? You don't calculate like an average concentration. You basically want to compute
If your
the
goal is to
total
measure average
pollutant content.
concentration, you do that way. So that means C average is C V multiple B and then R PI. We'll get to that in a couple of slides.
Okay, Professor, thank you.
All right, so again, these are the decisions you have to make. What type of pollutants you are going to samples, what are the different, where you are going to collect samples, and when you should collect samples, and whether you should use graph samples or automated sampler. Again, that's mostly this is based on cost. This is not really a choice here. If you don't have cost $10,000 to install that locations, you are not going to use auto sampler. Sample handling is important because that influence the concentration of pollutants. Again, as I said, you are collecting, if you are using graph sample, you should ensure that that particular sampler or the container should not have any pollutants. You have to clean it. How you clean it is depends on what type of pollutants you have. For instance, heavy metals. Heavy metals are present particularly in you never collect heavy metals in a sampler or in a container which is metal. So that's the common sense. So usually it's used for plastic bottles. Take plastic bottles, you put acid, that we can wash it. Acid dissolve any residual heavy metals in that plastic container. Then you pre-wash that particular container in the stormwater. So what you do is you take acid washed sampler, take some sample and pour it back in. That way you wash them any residual acid inside it. And then do that multiple times. That way you rinse in the same stormwater and then you collect that water. For organic pollutants, You typically use glass container because if you take any plastic, plastic might actually absorb some of the organics. So that's why you use glass container. For pathogen, it doesn't really matter. You have to disinfect before using methanol and clean it very well. And then as soon as you collect that sample, you have to store it at 4 degrees Celsius so that the pathogens don't grow or they don't decay. So these are the couple of things you have to remember how to change based on the types of pollutants. Same thing for
Professor,
storage. Yes.
I had a question. So, yeah, the sampling should be different for a combined sewer and a separate system, right? Like in case if it's a combined system, then you will see peak of pollutants different due to the mixing of the sample with the sewage water also. While a separate system is when you will actually see the first flush, right?
Yes, yes. Yes, so the question was if you are collecting sample in a combined sewer system, how you should consider it. Usually, if combined sewer system, nobody samples because these are wastewater. There's no
Okay,
point of
okay,
collecting samples.
okay,
This sampling is associated with just stormwater.
okay. So if it's purely stormwater, then it will be applied only in cases where they have separator systems.
So again, I didn't hear it clearly.
So when they're sampling stormwater, it is essential that for basis of the green infrastructure, you start out with a separated system instead of a combined system.
Yes, yes.
Okay. Thank you, Professor.
Great. All right. So in this particular slide, you should remember these three questions. Those are related to quiz. You should know based on the contaminant type how you should handle it. For organic, you should use glass container or you should not use any container that will absorb that organic. When it comes to heavy metals, you have to pre-wash with acid so that you remove any residual heavy metals. And for pathogen, you have to store it at 4 degrees Celsius so that it doesn't grow or it doesn't die. Again, the storage also depends on most of the time people store in a ice cooler. The reason is that if there is any pathogens or there is any organics, they will not be decomposed by the microorganisms in the system. So you never go wrong by putting in the 0 degree cooler. But if you don't have a cooler, immediately sip it as soon as possible and store it in the refrigerator. The reason we put in cooler is because to slow down the microbial decompositions, nothing else. So how do you handle the storage? Now, you know that you can measure immediately, but many labs are not open all the time. So that means you can store that samples for analysis for next day or other time. That storage is important, and the whole reason how to store is because you don't want the contaminant concentration to change during storage. For instance, nutrients. Nutrients, if you have lots of nutrients, nitrogen and phosphorus, any kind of microorganism present in your stormwater, and you have lots of them, they will start eating those nutrients. That means next time you measure it, it will not be same concentrations. So to ensure that your concentration is consistent, you have to remove those microorganisms. That means you have to filter that or you have to acidify it. If you acidify it, add just small quantity of highly acidic strong acid, in this case salt, HCl or um, hydrochloric acid, so that the pH is around 1 or lower. If you have low pH, no microbe will survive. That means they are not going to eat that nutrients. And a lot of times, many of my actually two of my grad students. You have a question? In fact, you never add nitric acid. It's NO3.
Thank you.
Because it is nitrogen. You are looking for nutrients. If you add nitric acid, you are adding nitrogen. That means you are changing the concentration of nutrients. We have a question in somebody's unmuted. That's why probably I misinterpret as asking questions. The next one is pathogens. For pathogens, they will die or they will grow. Either way, they will change. So that means you have no choice but analyze that concentration within 6 hours. So as soon as you collect sample, you should have somebody or you process that sample, immediately analyze that concentrations. If you keep it more than 6 hours, those samples are wasted. You have to throw them out. For dissolved organic, as long as you filter them so that there is no microbe to degrade it, you can keep it for at least a weeks or longer. But refrigerate them so that you can slow down the decompositions. And ensure that during storage, those organics are not really getting attached to the wall of that container. For sediments, this is very similar to pathogens because sediment particle size matters. Also, sediment concentration is based on particle size distributions. So that means the moment you collect sediment samples, you have to analyze within 1 to 2 hours. And before analysis, you have to really check it. The reason why you don't want to store it, because they will start aggregating and settling. Once they aggregate, even though you shake it, you change the particle size distributions. So that's why it's very important to analyze the sediment concentration within 2 to 4 hours. And so this is all that you have to think of. Again, how to quantify total concentration? It's a very simple equations. We discussed that here. It's called event mean concentrations. Means if you are collecting a samples and say during this storm event, this is the concentration of pollutants, that's based on actually many samples you collected during the storm events. So let's say you collected samples, I number of samples, n number of samples. N is number of samples you collected. And for each sample, there is a concentration, that's CI. This is concentrations. It's written here. And Q is the discharge, flow discharge. And you also measure the flow rate at that particular sampling location. And this is related to discharge. That means you are measuring flow rate at that pipe or rivers or any stream. So you multiply those, they get an amount of mass in that particular time. If you sum them together, you get the total amount of mass. And you divide that by total volume of the discharge, you will get the concentrations. So this is total mass discharged per unit time. This is total volume discharged. So there is a question from Arusi. Are samplers taken over the duration of the storm events or over the spatial extent of storm event? These are the samples taken at different time. So that, and the location is one location. You have one more questions? No, actually not any questions. So again, this is the concentration. If you think of this term is can be TMDL. If you think that time is day, this whole mass will be TMDL. So this is the next slides is all about TMDL. TMDL is the total amount of pollutant discharged at any time. So you see this equation over here. This is not similar to what we wrote before. It's because this is what we call CI QI. But this one is background concentrations, means even there is no storm event, if the lake, if that stream water always have some background concentration, you have to account for that, because it's all about how much total amount of contaminant discharge into the system. And then at the end, there is a margin of safety, because you might have, there are certain amount you may not account for, so always there is a margin of safety people are. So this is how they calculate TMDL for any locations. So if you want to know more about how TMDL develop, again, this is the link that you should read. This is just one web page. You should read that in 5 minutes and you'll know exactly how it is developed. And there are also other links. It can lead you to find out TMDL concentration or amount for different water bodies at any site inside US. So we discussed that. How do you measure the TMDL? Basically concentration times volume. So then I will not read through other slides. This is basically a different equation that you can use to determine the total amount of mass. I will derive those after this class so that you know how to use those equations for examples. So what I'll do is I'll derive these questions. So you have a final form for different types of water bodies. You can use that to measure the total amount of mass loading for the systems. Again, these are mass balance. This is already you learn in CE153. Anybody who doesn't, who didn't take CE153, you can learn it, relearn it here. But again, I'm going to record it later so that you watch it at other time. This is another examples. We'll use that to solve based on the equation you derive here. Again, this is all in CE153, so we don't need to really redo it again. So that's exactly 1 hour, and that's end of today's class. So hopefully you will be able to answer those 4 questions you begin. Let's go back to that question. I didn't have the question here. No, actually I have it somewhere. All right, so these are the 4 questions you should answer. What are the different regulations that affect stormwater management? Clean Water Acts, and there are many local regulations. You should be able to tell those. Again, I'm not expecting you to remember that for quiz or midterms. Learn the sampling method and handling. This is very important. You should know what pollutants are affected by different methods of handling and sampling. Learn the cause and importance of force plus phenomena. Cause is because most of the pollutant washed off initially. Why it is important? Because you can actually treat that to meet the regulation limit. So your green infrastructure has to be designed certain way to capture that force plus. We'll learn that how it is done. And quantify event mean concentration and total maximum daily load. You didn't know this one, at least not quantitative way. I'm going to record that so that you learn that. So that's end of the class, but you can ask any other questions. So Ashley is asking this question. Just to clarify, in the future, we have to watch the first half of the lectures, answer the learning assignment question, submit our answer on CCLE before class. Yes, but only if I ask you that question on so there will be a, on CCLE, I'll send you that question. So you all get that question there, and then you answer on CCLE. So that's basically quiz question type. I'll do multiple choice and you'll say yes, no, or you answer a couple of lines. And you'll receive that email from me. If you don't receive anything, that means I'm not expecting you to answer that, but at least you should read it. Do you have a discussion at 8 a.m. tomorrow? No, there is no discussion tomorrow because this is the first class and we will, the TA doesn't really know what, unless there is a lot of example problems solved. Would you be able to upload some source that given background in CE153? Yes, I can upload some of the mass balance slide, but again, those are not video recorded, so that means you should be able to read those and understand that. Just to clarify, are you going to over the example on the slides on the video recording? Yes, anything on slide will be recorded. I don't leave anything for you to do it, but I'll give some more example for you to discuss with the TA in next week. Did you decide on the PM discussion time? Yes, the discussion time will be, we can do that the second half of the class. That way, because you are all here, so you can discuss that anything you have related to homeworks. Or we can have a different days, but I'll send you a poll. How about this? We create a poll right now.
Renan already sent the poll out.
Okay, all right. That's Vera. Any other question? I think I missed, so the question is, I think I missed it, but how early will you be posting the part 1 lecture videos before we meet at 4 p.m.? It has to be at least 2 days before or at least 24 hours before. And this week, again, this is my mistake. I didn't record it. It takes longer. But I'll record for Tuesday and next Thursday. This weekend, I will record that, and you should have those by Sunday night.
You said that Measure W was 300 million for the budget. Could that be
Yes.
affected by coronavirus? Like, would it be cut or?
Well, I don't think I'm the person who can answer that, but I doubt, because these are already allocated, and I don't know how the state regulation works. But nobody knows how coronavirus will affect anything really. I hope not, but this is going to be a philosophical answer. If you can save life, that's the first thing people will do. So maybe LA County will look for money, and they might take somewhere, but I don't know. I don't know whether I can answer that. Have the video for lecture 2A being posted for pollutants? I have those in my computer. Let me see if not posted, I'll immediately post it after this class. And one more thing, those are all posted on CCLE, but also I'm creating a YouTube channel where I upload them in the series. That means it has more structure to it. That means you can always go whichever one you can check. The reason I like YouTube is because I can ask certain question and tag it for different times. So that means you can go to that particular time if you want to answer in futures. It's like a bookmark.
Just to be sure, Professor, was there like a second part of the first lecture that was recorded and posted?
Yes. It is already uploaded on CCLE. I uploaded it today, so that means you didn't get a chance to watch it. You can watch those. Those are very background information, not much quantitative. And anything I record, the nice thing about me recording is it's not a 1 hour video. It's a 10-minute based on the topic. So that means you don't have to watch or scroll it. You can watch 5 minutes and then you can come back and watch the second video. Whereas for this one, it's all 1 hour. I don't know how to break it. Maybe there is a software in maybe iMovie or something that will allow me to break into small pieces.
Right. Thank you so much, Professor.
All right. If you have no other questions, then we can conclude today's lecture.
Thank you.
All right. Thank you.
Thank you.
See you next.
Thank you.
Thank you.
Thank you. Thank you, Professor.